So I left this running for a bit yesterday, turned it off when I went to bed because I didn't want to leave it going all night long unattended. So going down the column, I've got time here. So after an hour, it pretty much was about where it was when I first started. Couple of hours, it picked up a bit, and by the early hours of the morning, it was pulling a few milliamps more. It's not a great deal because it's a 320 ohm resistor, so that's about 34. This is about 35.5 milliamps or so. Just rounded it off. So anyway, I've just decided to chuck a different valve in, and look at the slightly lower anode voltage because it's drawing a bit more current. It's loading the supply down with just 241 volts on the anode and 230 on grid 2, with minus 12.7 on grid 1. This valve is still passing 40 milliamps of cathode current. So with right, look here, a 1.6 volts more bias on grid 1 turning it off, it's managing to pull an extra 6 milliamps of current. So it shows the difference in emission. So I'm a bit curious because this one, well, this bar one over here was definitely one out of a batch. They've all got the same date code. Now, if you ever looked on like eBay, these actually come in big boxes of like 50 or 100. So they're all going to have the same date. You know what I mean? They didn't make one in 1986, put the box to one side in the factory, 3 years later come along and decide to make a couple more, shove them in the box and so on. So if you've got some from the same batch or the same, day of manufacturing or whatever, they're all going to have a similar date code. Well, the seller I got these off, he sent me a load of valves, all the same date code. So he obviously just literally pulled them out of a box and give me 12 valves. And this one's not the faulty one. That one over there is the faulty one. Now I have here a box that actually turned up the other day. And first thing I noticed straight away is you can see the pins have been in and out of, they've got bending and stuff on them, and you can see the little track marks on them where they've obviously gone in and out of a socket. And they're all completely different date codes: 1971, 1978, 1975. So you can see that's a huge difference. And they go all the way. Some of these are late 80s, I believe. So it says to me straight away that he's not just got a big box of these and he's selling them. It says to me that he's maybe using these, or these are some faulty ones he's brought, low emission or whatever, or he's testing them himself, and the ones that aren't meeting his spec when he tests them, he's flogging on eBay. So I'm going to plug some of these in and see what they do. I don't think this one's going to come back to life any more than it is. I think what I've got is what I'm going to get. So I'm just interested now. I somehow think that all of these are not going to be coming up to the same sort of level a good one is. So I've got my 12.7. I know on this jig a good valve is going to reach an equilibrium at about 40 milliamps cathode current and 12.7 volts across grid 1. Well, across the cathode, it's actually pulling the cathode positive is the same as pulling grid 1 negative. What this tester basically does is as it draws current across this resistor chain, that creates a voltage drop. Grid 1 is tied to 0 volts, so it's seen as a negative bias. Well, it would be exactly the same as if I was to take this valve out of this circuit or bypass this cathode resistor and apply minus 12.7 volts to grid 1, it would hold it at 40 milliamps. So it's cathode bias rather than fixed grid bias. I like this method. It reaches a nice equilibrium. As current tries to go up, grid bias gets even more, and it's self-limiting. It's handy when using an amplifier that isn't going to be owned by someone who's constantly going to keep checking bias values and stuff. And as the valves age, as their emission drops, they'll pull less current, so there'll be less voltage on grid 1. And rather than a large, if you didn't adjust a fixed bias valve, you'd see the current drop off like this. These will be a much gentler slope off because as current drops, bias drops, so there's less bias turning the valve off, so it's allowed to draw a little more current. It's a nice equilibrium. So anyway, yeah, I'm going to test some of these and see what I get. So I've pretty much confirmed my suspicions just on testing the first valve, it absolutely, once the cathode started warming up, it drew a huge amount of current. This went right up to about 16 volts, then quickly came down. That says gas current to me. So I've probed grid 1. See, I've got voltage on grid 1. It's passing gas current to grid 1. It shouldn't be contamination of grid 1 on an unused valve via emissive material off the cathode. So yeah, that's more likely to be gas. Now, this valve is dated, I believe. This one's dated 1971. So yeah, we're now 2018. So that, steady there, that is a 47-year-old valve, I believe. Yeah, 47. So sitting in a box for 47 years, there's a good chance a little bit of gas may have gotten into it. Now, the shiny material at the top of the valve, the getter, its purpose is to absorb any gas that is either outgassed from within the valve over its life or that seeps in around the seals. But in order to do that properly, it needs to be hot. So I'm going to leave this valve running and just see as the getter warms up if it absorbs the gas that's in this valve and whether this valve stops drawing grid current. Now, as I've been talking, this is dropping. As the cathode current dropping, says to me the amount of voltage on grid 1 is dropping, which means it's drawing less and less grid current, which is good. Yeah, look, 600 millivolts. So yeah, I'm dropping. It was when it first did it, I had to put it on a 20 volt scale to get a reading, and then it sort of sat around 1 point something. So it is dropping. So I'm going to say, obviously, he put this one in his tester. It just instantly come up grid current and decided to reject it. Now, if it's had a lot of gas in there, that some of that will have bonded with the emissive material on the cathode, especially on initial power on. It would have been massively attracted down to the cathode. So this one may well benefit from several hours in this jig. It might come back to life. This one over here, it has a little bit, so it's probably going to be worthwhile repeating the procedure for this one. But I've got a tray of, how many's in here? 2, 4, 6, 8. So there's 8 in total. So it's going to take a while, but basically I'm just going to go through all 8 of them and see what sort of range I've got. Next one I put in, I'm going to record as I fire it up, because I wish I'd recorded that. It went flying up. I thought I was going to have to hit the off switch before the thing went into full meltdown, but it started pulling down again on its own. So yeah, it is stabilising. I'm going to come back to it. I'm going to go have a cup of tea and just leave this running, come back to it and see where it is. What it present, 1/4 volt on grid 1 and dropping. So realistically, if this is a sort of 20 millivolts or so, that's fine. Even a really good valve's going to have some small amount of grid current. It's just the nature of the way they work. There's always going to be some residual gas in the valve. So hopefully this one's actually a good valve. It's just got a bit of gas in it after 47 years, and it just needs a while to warm up and let the getter do its job. Well, it's had a little while. The cathode current seems to have dropped off a little bit more, so going to check the grid 1 voltage. If I come to here, yeah, look at that. Considering it was up over past 2 volts before, and that is now, yeah, that's just random noise basically on grid 1, which is what you'd expect. So yeah, if I actually, when it goes high like that, that's me actually just losing connection on the probe. It's just, you know, actually when it's on. So yeah, class that is now a working valve. So it says to me, old mate who's tested this is probably just put it in his tester. It's come up leakage, and he's just thought, screw that, shove it on eBay, and he's put it in the box with other ones where he just shoves them on eBay. So I'm going to shove another one in, and I'm going to film it this time to see if it does the same thing as this when it first comes to life. Right then, number 4, see what happens. Here it goes. So yeah, I've been getting some interesting readings off these valves. Some of them have took a while to wake up and increase in emission. Some of them have gone up quite high on emission and then started to drop back down again. So they certainly, all of them do not read, that I've tested so far, do not read what the good valves I got from the ever eBay seller were like. They, apart from the one I rejected, they were straight up there, no grid 1 current, good emission. Like for instance, so this one here, right, it's not passing any grid 1 current, but you can see emissions way down. It's at the same level as what a couple of other valves I've tested from this batch are. Well, I say batch, they're not from the same batch from this delivery, I suppose is the word. And they're on par with the valve that I'd rejected out of the good batch for having low emission. So yeah, I'm still going with my theory that the seller of these ones that test either leaky or low emission, he's just selling on eBay as job lots of 8 to 12 valves and stuff. Because like I said before, if he just had boxes of the things, you know, if I've got several boxes of valves of the same kind, let's say I've brought from a warehouse a whole job lot of 1,000 valves, they're still going to be in their boxes unopened from whether they're early 70s up to mid 80s, 90s manufacture, whatever. So if someone comes to me and wants to buy 10 valves, I don't randomly pick them one valve out of each box. I just go to the nearest box and pull them 10 valves out. The fact these, you can sort of see scuffing on the pins. Well, that's because they've been in and out of a valve socket, which means someone's plugged them into something to test them. And like I said, with all the different date codes, it says to me that the seller of these valves basically tests them, and if they read low or leaky, he just decides to shove them on eBay as new old stock. So basically, if you are going to buy new old stock valves off eBay, now getting ones that are all the date code the same isn't guaranteed that you are getting some genuine untested new old stock, but I would say if you're getting the same date code, there's probably more of a chance that they are just randomly picked out of a box of new old stock valves than ones someone's tested and decided aren't good enough for the uses he's going to use them on, so he's shoving them on eBay cheap. So yeah, anyway, I'm still going to keep testing these. I'm really hoping I get another one like I did on that bloody one where it had huge amounts of gas current. Because that was kind of cool, just watching it. It went really high. And watching it actually slowly come down, it's the same time as the grid 1 current just came down. Obviously shows the getter, the bit at the top of the valve, did its job. It absorbed the gas in there. And the valve went back to behaving as it should behave. This one looks like it's got a bit of a, almost like a crack on the glass, but it hasn't. It's just a bit of a mark. So yeah, anyway, hopefully get another bloody bad one in a minute. This valve is dated 1972, so I've got high hopes for it. You can see, even without the cathode warmed up, I'm getting fluctuations on my meter. So here it goes. So hopefully those fluctuations are a little bit of gas current, but we shall see. Now that's stabilising way too early to be gassy, I'm going to say. Sorry, I live in a town in Lincolnshire and we have a lot of Eastern Europeans, and obviously they do a lot of land work and stuff, and they do like a bit of drink, so they work odd hours and all sorts. Anyway, somewhere just round the corner from me there's a bloke, I'm guessing he must have a few beers and then go to bed, because sometimes his mates come to pick him up and they're screaming and banging and beeping the car horn, and all I can hear in my right ear, he's getting louder and louder and more aggressive sounding. It sounds like he's going to put his door through if he bangs any harder. Can't understand what he's saying. It sounds Polish to me, but it just makes me laugh. You think, how can you be that out of it, that you've got two mates banging and shouting at your door and you're still not getting up? It sometimes takes them about half an hour. You hear them get in the car and they speed off flat out, obviously late for wherever it is they're meant to be going, but You probably can't hear it on the phone, but it is hilarious. Anyway, so yeah, another working valve, just a bit down on emission. Seeing a trend here. They're all actually, all of these are right. Maybe these older 70s ones actually are a bit lower emission. Maybe they might have changed the compound of the coating or something in the later years of manufacture. Because all of these 70s ones I've tested so far. No, that's wrong. Yeah, because early 70s, late 70s, late 70s. So yeah, look, the early 70s ones and lower emission in the late 70s ones, they're pulling nearer to 12 volt. And the 80s one was pulling a 12 point. I haven't got it written down. It was pulling a 12.8 or something like that. So yeah, 12 volt, 12.2 volts. Saying that, look, there was a slightly higher anode voltage at that point. That might just be why that's up. But I wouldn't have expected to see an extra half volt across the cathode resistor. I mean, that is a possibility. It's highly possible that later ones were built to a slightly different spec and it made them a slightly better slightly better emission. But these are all reading on par with, like I said, I know I've said it a few times now, they're sort of reading on par with the one I rejected as being low emission. So, you know, if I put them in an amplifier with that valve, I've got 4 equalish valves. So maybe the other ones I've got a high emission and these are normal emission. A bit hard to tell, really. You know, you sort of, when you're dealing with 40-plus-year-old valves, it's a bit hard to say what they were like when they first came out of the shop. So, like I said, though, my original point is true still. You can see all of them have been in and out of valve sockets. So they still very much been in a tester. And technically, although this is a very, very crude valve tester, it is still a valve tester. It's what I knocked it up to do. But right. So yeah, obviously this I'm writing down. I'm putting a pen number on all of the valves and I'm keeping a note of what they were, and I'm going to put this piece of paper in the tub with them, so when in whether it be 6 months or 6 years time I go to use them, I can at least look down here straight away and pick, if I'm using say a push-pull amp, I want valves that at least on idle are going to pass the same amount of current, so at least it gives me an idea of, you know, which ones to use. See, this one's waking up a bit. I think it was sort of at 11.2 or something, 11.3. I'd have to look at the start of the video, but you can see it's waking up. But of course, that might just be because the anode voltage is risen a bit. I never checked it at lower voltages. I've got the dryer on, and there's the heating elements kicking in and out. Obviously, it's making my mains voltage fluctuate. So it's obviously going to make my power supply voltage fluctuate, and because this isn't a fixed current supply, well, it's not voltage regulated supply, it's just a capacitive multiplier. It's as the supply modulates slightly, the current through the valve is going to modulate slightly. But no, look, I think that is waking up. I'm giving them all half an hour anyway. I'm not just like giving them 5 minutes. I'm giving them all about half an hour to wake up, get warmed up and see where they stabilize at. At least having ones that are all the same, it means I can use them. You know, it's not like I'm going to just chuck them all in the bin. And the one even with the gas current is stabilized. I'm going to plug it in again after I've done all these and see if it's still behaving itself. I've got like boxes and boxes of valves. I should really, I mean, the potential's here. I could put a few more sockets in this and actually do a proper job of wiring it up. I could put like some switches on it so I could select different cathode resistances and, you know, actually put a voltage regulator in it, because it's part of a big box. I could actually turn this into some form of valve tester. You know, I could put like some little points on it where you could put the probes into probe cathode voltage and stuff. And, you know, have different sockets for dual triodes, different kinds of output pentodes, octal pins and that lot. It's an option. say, look, it's dropped down again now. So, but yeah, at present, just for messing about for today, it's good enough. But it's a possibility. I've got a chunk of time off coming up over winter. If I get bored, I might actually turn this into something if I can be asked. But anyway, carry on testing. 1979 vintage, this one. Let's see what it does. Alright, here it goes. Oh, that's climbing well. Alright, I've got 400 millivolts, 5, look. So I'm passing grid current on this one, and it is rising. Okay. So without that 0.5 volts on the grid, that cathode would only be, what, 10.8 volts? Yeah, about 10.8, something like that. So yeah, I'm still rising, look. Grid current is rising. Interesting to see what happens here. I don't have my crocodile clip for the end of my probe handy. Well, the other one went right up to over 2 volts before it started to come back down again, so give it a little while. It's not passing excessive cathode or anode current, so I'm going to give it a little while and see what it does. Okay, I've clipped my probe onto it. As can be seen, that residual gas that was in the valve that was causing that cathode current is now the getter is starting to warm up. That gas is starting to be eaten up. So should see cathode voltage drop a bit as the grid voltage drops. Yes, see, it is fluctuating and going down, yeah. Well, hopefully it will do like the other valve did and go to zero. I mean, the other valve had an awful lot more leakage in it than this one had. Just shows, you know, if you're just buying these and shoving them in a guitar amp or something, you have no idea. If you've got no way of testing it and just going on good faith, you could be really doing some damage. So to anyone, if you're going to buy new old stock valves, you need some means of testing them before you put them in the amp. And if you do put them in the amp, then you need to have some means of actually monitoring what they're doing for the first couple of hours, really. You know, when I build a valve amplifier, once it's up and running, for the first couple of hours it's just left idling, and I keep sort of every 5 minutes checking on it, because, you know, valves can suffer all sorts of internal shorts and various failure nodes. For instance, you know, as the valve gets hot, maybe there's a minute crack around one of the pins or something which opens up and slowly starts letting gas in, and, you know, you're not near the valve. It seemed fine when it fired up. A few hours later it's passing huge amounts of gas current. That's enough to quite happily take a output transformer with it, and if you've only got a small power transformer, it can take that. I've seen, you know, electrolytic Jesus, my tongue's getting tired today. Electrolytic power supply capacitors all just bulged open and completely dry where they've been put under so much strain. Connectors on the board all fried, all manner of things just from valves that have gone gassy, pulling such a huge load off the HT. And yeah, there's many a output transformer and mains transformer being burnt up because of a couple of knackered output valves. So yeah, if you're going to buy NOS valves, either buy ones that have been tested and guaranteed, or find some means of testing them before you use them. This is looking like it's going to be okay. It's slowly dropping off, so I'm going to let that go as low as it wants to go, put a note on my paperwork of what it settles at, and move on to the next valve. So out of the bunch of them, I had one that drew a lot of grid current, obviously through gas inside the valve, which quickly cleaned up, and one that drew a small amount of grid current, but nothing major. So I've got a sort of, if I go down the scale, they're either down in the lower 11s on emission or just kissing the 12 mark. This was the old one. This is out of a completely different batch. This is a 1980s one, which is emitting low compared to the others. So yeah, they're all sitting between 11 and 12. This one's just gone over 12, but it's not drawing any grid current. So yeah, I don't really know what to conclude from that. I'm still of the opinion that the reason these are all different date codes was because they've been tested and they didn't meet a certain spec the seller was after. Or whether he himself brought them as a job lot and they're basically someone else's discards. I can't say. I'm speculating really, but yeah, the different date codes and the obvious signs on the pins that they've definitely been in and out of valve sockets recently. You know, the oxidization on the pins is scraped where you can see the marks where they've gone in and out of the socket. So I'm going to say someone's put them in a valve tester. Now, it could just be, I suppose, that the bloke selling them wants to at least test that they heaters work and that they emit before flogging them on, but you'd have thought then he would have noticed the ones that were leaky and stuff, unless he just didn't test, unless he literally was just bang, bang, in, out, put them in 20 seconds, yeah, they're emitting, next one. Who knows, but it's just odd that they're all different date codes. That's what makes me suspect. So I've got a few more of these. I might, some 70s ones, I might put them in the tester, I might not. I think I need to have another cup of tea. It's a very British thing to do. All right, look. Passing a bit of grid current, that's risen. Yeah, oh, it's up. It's going up. That's interesting. Let's see what happens here. If I disconnect the grounding wire off this capacitor, so stop smoothing it out. Yeah. It is pulling some grid current. That's interesting. It's warmed up. So yeah, that would be closer to the 12 mark if that grid voltage wasn't elevated. So yeah, well, I mean, look how long it took this one to start doing that, and I've had it on a proper jig. If that was on a valve tester that was only putting sort of 30 volts across the valve or something, I'm not sure what they run at. I know they don't run it anywhere near the actual voltage the valves run at. You know, it wouldn't have picked up on that leakage. And now it's rising. That's interesting. So anyway, yeah, that's just another random video of the things I get up to. It's the sort of, anyone who messes about with this stuff will do things like this. It's a necessity. It's no good buying a load of valves and just assuming that when you put them in a piece of equipment they're going to work. You need to test them. You need to see how they're going to behave. If this one keeps rising instead of sinking, this is going the wrong way. The other ones, they come on, rise very quickly, then slowly go down. And this is going the other way. This slow rising makes me suspect that there might be a hot spot on the cathode or something that's heating grid 1 up, or that it's outgassing from somewhere, or again that the heat's maybe cracked around one of the pins, it's opened up a tiny bit and is letting gas in. It might go back down, it might keep rising, but hey, look, it's on the up. This one might be one for the bin. I'm going to run for a bit and I will see where it goes. Well, this one is definitely no good. It's just been slowly rising and rising. So I've bypassed the grid 2 resistor. So obviously if it draws a lot of current, too much voltage drop across the grid 2 resistor, it'll limit the current through the valve. So there's one thing left to do, is bypass the cathode resistor and give this valve at least a send off. Now, in my last video, I saw how EL84s explosively die, or lack thereof. They just kind of glow and stop working. So I'm going to do the same with this one. I think what I'm going to do is just, how can I get to do? I'll either power it down or do it, if I can get this onto there. So you see that dropped to 0. Interested to see what the grid 2 voltage, 1 voltage does. Woohoo! No idea how much current that's drawing, but it's drawing some current. Let's just see, I have curiosity. Yeah, look, a massive blast of current has not helped it. In fact, it's done quite the opposite. It's rising even, well, yeah, knackered valve. So what I think what's just happened there, that is what's called outgassing. When you heat up a metal structure, like the anode, too hot, gas particles and stuff trapped within the metal will come out of it. It's called outgassing, hence the gas comes out, and then they obviously get into the valve and start creating gas current, and which is what's happened here. So you can see the getter's absorbed some of it now and it's starting to drop. I don't think it's going to become a working valve again somehow though. Right, so I gave it a little while just to see if a little shunt of heavy current would have done anything, and it didn't. So I've bypassed the capacitance multiplier supply because I don't want that going up in smoke, and besides I want as max power as I possibly can into this valve to destroy it. So let's bypass this cathode and see what she does. No, not quite got there. Come on, this is tricky. Come on. Ah, bloody hell. Just fun with one hand, it really is. Alright, that's bypassed. Well, it's glowing well. What was the date on this one? Oh, hard to see now, it's glowing a bit. I think it was a 79, I'm not sure, 76, 79. Anyway, it is no more. It is a knackered valve. Even with the cathode resistor bypass, look at that. That's the grid 1 voltage. It just shows how much grid current is passing. You can see she's starting to get some gas in there now. Look at that. So 220,000 ohms at 220 volts would be 1 milliamp of grid current. So at 22 volts it would be 100 microamperes. At 2.2 volts it would be 10 microamperes. And at 0.22 volts it would be a microampere. That's correct, I believe. So between 1 and 2 microamperes of grid current, which doesn't sound excessive, but considering there should be pretty much none, considering this grid voltage shouldn't... It's certainly dropping off now, isn't it? Look. Ooh. That's interesting. That valve's clearly going to be no good now. Alright, I'm getting a negative grid voltage. There you are. That, see what's happening there is the grid is getting so hot, it is now emitting electrons. Is it emitting electrons? No, that would make it positive. I don't know what's going on there. I'll have to think about it. It must be collecting electrons from the cathode. It has to be. The cathode's, you know, the grid must now actually be collecting. The cathode must be so positive. No, the cathode is negative still. The grid, I don't know what's going on there. For somehow the grid is now at a lower voltage than the negative rail. Somehow it's collecting electrons. I don't know how. I have no idea. I'll have to think about that one. But yeah, kind of cool. Maybe it's gas current from the cathode to the grid. Maybe. Who knows? Something weird going on anyway. Oh, it's going back the other way. It's not dying yet, is it? You're losing 17 millivolts across the cathode. Yeah, who knows? Who knows? The valve that wouldn't die. Smells nice and toasty anyway. What happens if I remove the cathode bypass? Seems criminal to destroy a 40-odd-year-old valve like this, but if it's no good, it's no good. It's got no usage. Maybe that fixed it. Maybe that'll maybe it'll go right back down to zero now. It'll be a fantastic valve with many thousands of hours of use ahead of it. These are the EV rated, which were for Russian military, which were actually rated for 10,000 hours useful life. There you are. It just needed fucking to fix it. I'm drawing, look, you notice I'm drawing very heavy cathode current now as well, because I've got the power supply bypass, so I'm putting 300 odd volts across this valve instead of the 200 odd I had before. If I remove this, it almost reads normal, but I know otherwise. I know there's no way I'm going to be using this valve on anything, not after the sustained abuse it's just had there. Maybe I got the getter that hot, it actually gobbled up all the gas in the valve. Yeah, sort of kind of what you'd expect, to be honest. That's where it should have been from new, but they can't ever risk using it, because if it did it once before, it's a good chance it'll do it again. And after that abuse, I imagine that severely distorted some of the inner structures within the valve, and it certainly will have done the cathode no good, that's for sure. Well, it's showing some good emission now, look. Showing some fantastic emission. I don't know. I'm tempted now. I'm just going to leave it running, I think. I'm going to put the grid 2 resistor back in as well. Give me a second. Oh, there you go. That is now reading as an OK valve. That is just weird. Look at that. Something happened that I don't know what that negative grid voltage was all about, because like the cathode, when it emits electrons, if there's a series resistance, then it gets drawn positive. So for instance, when positive gas particles collide with the grid, although it's not emitting electrons, it's the same as emitting electrons, it's gaining a positive charge, and so it goes positive. To go negative charge, it would have to be receiving electrons, just like the anode does. You know, in say you have a transformer coupled amplifier, as you increase anode current, because the anode receives more electrons, the anode voltage drops down. So for the grid 1 voltage to go negative, considering grid cathode was slightly elevated above the 0 volt rail, it had to be, because there's a slight series resistance with all the wiring and everything. On grid 1 I was reading positive. Well, where's my negative? I mean, was reading negative. I mean, negative meter probe goes back to the same point I'm drawing the cathode current through. That's just really weird, because yeah, if I was to put the positive meter probe at the valve socket end of this cathode wire, it would read positive, because there'd be a voltage drop across this wire. So for that to read negative, that's some weird thing going on, where it must have been being bombarded with that many electrons. It was actually somehow pushing a negative charge into it, which was then working its way back to here, which was being seen as a more positive charge via the meter internal impedance somehow. I don't know. But anyway, look. One of the best grid current readings I've had off any of these valves now. And I'm getting about right where I should be on the emissions. I'm going to just leave it running. I might just leave it running for the rest of the day and see what it does. This is just really freaky. That's like now technically a knackered valve, which is telling me if I just pulled this out and tried to test it now, it'd be telling me it was a good valve. I don't know. Well, it's been a while and this is measuring absolutely perfect. It's one of the lowest grid current valves I've got out of the bunch. Now, I'm going to speculate here. I've just been thinking about this for a bit. When I first powered it up, it was showing no grid current. It was only as the valve started to get warm that it started to show grid current. Now, that makes me believe, rather than gas current, that there was a slight contamination of the grid with some of the emissive material off the cathode. So as the anode warmed up and started reflecting heat back into the grid, and obviously there was some heat from the cathode getting to the grid, it was just heating it up to enough where it would start emitting a few electrons and gaining a positive charge. Now, when I shunted the cathode bypass resistor out and put the valve at full voltage, to start off with, the grid voltage was still elevated, still positive. It was only after some period of time it went negative, and I'm wondering if that was because there was such a huge current of electrons in the valve that they actually bombarded the grid and pulled whatever it was off the grid that was emitting those electrons. And at that moment, that was why all of a sudden it went from being positive to negative, because then the incoming flood of electrons were hitting the grid at such a velocity, there was actually some of them were imparting a negative charge into it, which then meant that the actual 0-volt rail was seen as positive, and it was allowing a small current flow through my meter, indicating that the grid had a negative charge, which would also now explain why, after putting it back to its proper operating conditions, I'm not getting this elevated grid voltage anymore. In fact, I'm getting a really, really low. This is fantastic. This is nanoamperes of current, I would say. Well, 220 millivolts is a microampere, so 2.2 millivolts is 100 nanoamperes, so I'm getting about 200 nanoamperes of grid current, I think. I could be wrong in the maths there, I'm just doing it in my head, but anyway, it's very, very low. So yeah, that's the theory I'm going with anyway, was that there was contamination of the grid 1 structure. Huge flood of electrons just bombarded it, blasted it off, and now it's gone. It's running fine. But the question is, what do I do with this valve? I mean, like I said, they're rated for 10,000 hours and it's measuring good. I can put a battery across it and modulate the anode current with grid voltage with ease. It behaves as it should do. I don't know, I was looking online and I see a website I buy bits from has some like 3 watt rated single-ended transformers with 40 milliamps primary current, which would just be perfect for a small single-ended design. So I might build something with them and like use this valve as one of them, just a small little single-ended amp. I can put something inside it, so I can run it from a current sink, so that if the valve does start drawing excess current, it won't actually hurt anything. Or I can put, you know, something like a cathode resistor in there with a small op amp across it set to shut the amp down under excessive current conditions, which would be good anyway, whether you've got good valves or not. So that would be a good thing to have, because you can just plug in and forget about it until it's time to sort it out. But I don't want to chuck this valve away. It's measuring too good. Even though I know it's just been through one hell of a stressful situation, it's still measuring better emission than some of them, and it's measuring lower grid 1 current than some of them. It's the split of grid 2 to anode current is where it should be. About 1.5 milliamps to it's about 38 milliamps or something like that, 40 milliamps, whatever it worked out to cathode current. So it's a good split. You'd expect to see that with a beam tetrode. You'd see a much larger split from anode to grid 2 current than you would with pentodes. So yeah, anyway, that's my theory on it. If anyone else has got any ideas, feel free to leave them in the comments section. This is how we learn. So it's interesting because in science the term theory is often mistaken for the general vernacular theory. Obviously in science a theory is a tested and proven idea. For instance, theory of gravity, theory of force, theory of energy conservation, all these things, they're always called a theory because they're adaptive. They never say this is an absolute, this is the way it's going to be forever. They say our best evidence and testing has shown this at this moment to be true. However, we are willing to alter it should something else come along in the future, which we have to incorporate or adapt this theory to suit. So it's hypothesis. I can't pronounce hypothesis. Hypothesis, that's the word I was looking for. As a hypothesis is an untested idea, and then once it's tested and proven, it is a theory. So yes, one hypothesizes of the mode of operation here. I'm trying to find the words I want. There's nothing like putting a camera on and trying to speak into it to make your brain go completely blank. I tell you, it's fantastic. It really is. So yeah, anyway, so I've completely gone off on a tangent. What was I on about? So anyway, yeah, if you've got any ideas as to what might be going on here, or absolutely know the answer for certain, feel free to comment. And yeah, thanks for watching.